Okay, here's the notation. It's going to say a function with the divided by sign, or it could be written divided by sign inside. You don't have to know the vocabulary, but I'm going to use the vocabulary: dividend, divisor. Do you know what the answer to a division problem is called? It starts with a Q. Quotient. Yep, so you've got a dividend. Huh? You never heard dividend, divisor, and quotient? So anyway, I'm bringing it back. The dividend is what is being divided. The divisor is what you are using to divide. And the quotient and remainder are part of your solution. So guess what? We're using the box method. So would you agree that when you multiply, you don't have to write this down, but isn't 3 times 7 21, right? Well, isn't 21 7 divided by 3? Or sorry, nope, that doesn't make sense. Isn't 7 21 divided by 3? So we're going to basically work backwards. We don't know both of these numbers. We're being given the dividend and one of the divisors, one of the factors, and we're going to use that to get the quotient. So when we've been doing multiplication, we would write the two different factors on the outside of the box, right? Well, one of the factors is x plus 2. So x plus 2 times something, which is going to be our quotient, is going to give us our dividend. So our dividend is going to show up in the box because multiplication would have been this times this gives you inside the box. We know the outside and the inside of the box. We're going to use it to work backwards and find the outside. So what you do first is you stick the first term of your dividend inside your box, 2x cubed. And you ask yourself, what has to go in this position out here so that this times x gives me 2x cubed? So 2x squared is the first part of your answer. This is your quotient that we're building up here. This is going to be the quotient. All right, so then, do you see a box that you could now fill in that you know what it is? What box can I fill in now? This one right here. What has to go in that box? 2x squared times 2 is 4x squared. All right, so now I'm stuck again. So now I need to go back to my dividend. How many x squareds are in the dividend? 5x squared. How many x squareds do I currently have inside my box? 4x squared. So how many x squareds need to go on this diagonal so that these add up to the 5x squared that I need? 1x squared. Right? Remember when we did multiplication, the diagonals ended up being like terms? All right, now I can do the outside of the box again. So what has to go in my quotient to make this true? So x, right? So plus x goes in my quotient. So x times x is x squared. Now, do you see another box that you can fill in? The bottom. So what's the bottom box going to be? 2x, yep. All right, I look at my diagonal. What did I need? I needed negative 3x, but I currently only have 2 x's. So what goes, so I need negative 5x to go here. This is actually going to be the end of my quotient. What's the last term in my quotient that's going to go here? So minus 5. So that is your quotient. Now you need to find your remainder. So the last box is going to tell you your remainder. So what's this box down here? Negative 5 times 2 is negative 10. All right, what did I want to have inside my box? I wanted to have positive 4. I ended up with negative 10. If you end up with positive 4, there was no remainder. It went in evenly with no remainder. What does my remainder have to be so that this will add up to 4? 14. So it has a remainder of 14. So my quotient is 2x squared plus x minus 5 with a remainder of 14. So it takes a lot of your multiplication knowledge and is just doing it in reverse. But division seems to be, pretty tricky because you've never seen this before, or at least this method. All right, let's do the next one. So this time, I'm going to put x minus 1 down the side because that is one of my factors, right? I'm doing division, so my divisor goes down the side. I think we need 4 boxes this time. See how I'm starting out with 2x to the 4th? Yeah, you could have called this an extra box if you wanted to. Actually, I'm going to need 5 boxes for this problem if you want your box to go further. So it's okay if you don't know how many boxes you need. I just add them as I go. This one will probably need 5 though. Okay, so 2x to the 4th. That is my dividend. So that goes inside the first box. So do you see how you do outer, inner, outer, inner, outer, inner? So what's the first term in my quotient? What times x? This will make you really good multipliers if you'd use this as practice. So what times x is 2x to the 4th? All right, what do I do next? So I have the dividend number. I'm going to see what can go out here, right? So that has to be 2x cubed. It's always going to be 1 degree lower, right, than what you started with. All right, so then I do this bottom box, right? 2x cubed times negative 1 gives you negative 2x cubed. So this is your diagonal that's going to have all your x cubes. How many x cubed do you need to end up with? Positive 3. So what do I put in this box so that it adds up to positive 3? Positive 5x cubed. So you're not actually putting this 3x cubed anywhere. Those two together add up to that term. All right, so now you do the outside of the box and the inside of the box. So this is going to be plus 5x squared, right? Because 5x squared times x is 5x cubed. This bottom box is going to be negative 5x squared. All right, how many x squareds do I have to end up with? Negative 2 of them. If I'm already in the hole, negative 5 of them, how much do I have to add back to get to negative 2? 3x squared. So together that adds up to negative 2x squared. So what goes up top? Right here, what times x is 3x squared? It'll be plus 3x. 3x times x is 3x squared. 3x times negative 1 is going to be negative 3x in the bottom here. Hard to see. I should have made my boxes bigger. All right, so how many x's do I have to end up with? Tricky question. 0 of them. Do you see how that term is missing up here? So if I have negative 3x, what do I add to it to end up with 0 x's? Positive 3x. So if you're missing the term, it has to add up to 0. So the last term is going to be what? Plus 3, because 3 times x is 3x. So that's the end of my quotient. Now I need to figure out what my remainder is. So 3 times negative 1 is negative 3. If it said negative 3 in your function, there would be no remainder. But we wanted it to say positive 8. So what do I have to add as my remainder? 11. So my remainder is 11. So I have this long function with a remainder of 11. All right, I would like you to try example 3. The question is this a factor? So basically they want to know, do you end up with a remainder or not? So you're trying example 3, do the division, and then it says, if the polynomial is a factor, find the corresponding 0, or find the corresponding x-intercept. So why don't you take a minute to try that one, and I can walk around and maybe help you. Leave it up for a second, and maybe you can check. But because I ended up with negative 21, which is exactly the correct amount, there's no remainder. So they said, okay, that means that x plus 3 is a factor, so negative 3 is a 0. Right? From our last unit, once you have a factor, you're able to determine what the x-intercept is. We're going to end up seeing that again on Monday, practicing zeros. All right, so example 4 is asking you, it's a little bit longer problem because you've got x to the fourth that you're starting with, but this time they want to know, is x minus 2 a factor of this? So if you end up with a remainder, it's a no. If you don't end up with a remainder, it's a yes. And then after we do example 4, we can try example 5 together because you're going to have 3 terms in your divisor, which makes it a little bit more challenging. So try example 4, and then we can do example 5 together. Right? So yeah, see, Remy, the 9x squared pops in that box. We were trying 4 on our own, but we're going to do 5 together in just a minute. So if you don't want to copy 4 till another time, that's fine. So it's going to be 2x squared is the first part of our quotient. Now you've got 2 boxes underneath it that you can fill in. So I do 2x squared times 2x. Well, 2 times 2 is 4, and that would give me x to the third power. And then 2x squared times 1 is just itself, right? 2x squared. All right, so you follow the same step for the next box. You have this 4x cubed, and you have this diagonal box. How many x cubes do you need to get from the dividend? -1 of them. I'm currently at +4 of them, so how much do I need to subtract to get to -1? -5x cubed. So together, those like terms inside the box add up to -1x cubed. So now I can do the top of the box. Right, and so if you started with a quadratic, now you're already down to a linear term, and it's going to be -5x, because -5x times x squared is -5x cubed, and now you can do the 2 boxes that are underneath it. So -5x times 2x is -10x, and then -5x times 1 is itself. Here's the kind of trickier part. Because this had a trinomial, you end up with one. Oh, wait a second. Did I do something wrong? Oh, that should have said x squared right there. -10x squared, right? So I have this term that's x squared, this term that's x squared, and this term that's x squared. So these 3 green terms along the diagonal have to add up to, oh, this is tricky, 0x squared, right? Do you see any x squareds in the original dividend? I have to add up to 0, right? If a term is missing, we said you have 0 of them. All right, how much do I currently have? It looks like I have -8 altogether. So I need +8x squared in this box to add up to 0 altogether, right? I have +2, -10, so I need +8. So that adds up to 0 on that diagonal. So the last term of my quotient is just a +8, right, to get me 8x squared. That's your entire quotient. So anything after this constant is going to be a remainder. So I need to fill in these 2 bottom boxes. 8 times 2x is how much? 16x. 8 times 1 is itself, just 8. Let me do it in another color. Okay, so this next diagonal, I'm going to call the red diagonal. That has to add up to the number of x's in the original dividend, +4x. So I'm currently at what? 11, 16, and a -5. So that's 11 x's. How do I get to 4, -7 x's? So that is going to be part of my remainder because I can't write anything else up here. And then the other box, I'll call it my, I don't know, purple diagonal box right here. Oh, I guess that did not write very purple. What do I need to get? I need to get -2 in the dividend, and this is a +8. So I need a -10. So when you add up everything inside the box, you should get exactly what you started with in your dividend. This is your quotient. Your remainder is -7x minus 10. So it's okay to have a binomial remainder. All right, so this other problem, I like that this keeps throwing in some geometry to help you review your geometry skills from last year. So the length of your rectangle is 4x squared plus 12x, right? 4x squared plus 12x. The area of the rectangle is inside 24x to the fourth plus 72x cubed. What is the width? Well, how do you find area? Length times width, right? So actually, you only have to worry about the first term, right? Because what times 4x squared will give you 24x to the fourth? Can you figure that out? What would you say? What times 4x squared is 24x to the fourth? This would be a really good multiple choice SAT question. It would be 6x squared. So if it works for one of the terms, it should work for the other term. If it was 6x squared times 12x, that would give me 72x cubed. The last question on here deals with volume. And it says the length is 4x squared. The width is, what is the height here? So 6x cubed, and the height we don't know, and the volume is 48x to the 8th. What's the height? Remember that length times width times height gives you volume. So what do you have so far? 6 times 4. What would you need to multiply to get to 48? And then you have x cubed times x squared. What else would you need to multiply to get to x to the 8th? So see if you can select the correct height. You don't need division on this one, really, but it's thinking about volume of a geometric figure. And I think there's one like that on your homework, 5.3 or 5, I forget. Maybe it's not till 5.4, but. Oh, perimeter was on the previous one with addition. You're right. So let's see. 6 times 4 times, it would have to be 2. All the choices have a 2, right? Is 48. X to the third, x squared. That is only x to the fifth. To get to x to the 8th, I would need x cubed, right? So choice A. Did you choose correctly?